Hi, I'm Marcy, and I'm with Jared and Priya to discuss current hand therapy methods and our proposed idea to augment technology for treating the thousands of patients who suffer from subacute stroke hand paresis. Hand therapy treatments are concerned with injuries and conditions of the upper extremities. Specifically, mirror therapy and electrical stimulation both work to improve recovery for a range of hand conditions, including subacute stroke. Mirror therapy, first used for the treatment of phantom limb pain, maps motor movements through neuron excitation to physically train the muscle while also utilizing the healing power behind triggering patient self-confidence and motivation. Electrical stimulation excites muscle fibers to promote preservation, recovery, and improvement of muscle function and mass. Recently, Schick et al. Studied the benefits of adding mirror therapy to EMG-triggered eStim, and we propose a way to validate the inverse of their claim.
We hypothesized that the implementation of EMG-triggered electrical muscle stimulation as a supplement for mirror therapy for the purpose of hand rehabilitation will allow subacute stroke patients to recover more quickly than treatment through mirror therapy alone. Our system works as such. Our healthy arm is sensed using an EMG sensor. That signal is then transferred to a processor, which then triggers an NMES unit to stimulate the targeted hand. At the same time, the user is positioned such that their reflection of their healthy arm is imposed over the top of their targeted arm. And in doing such, they are able to visualize the reflection as their targeted arm as it moves.
With our device, we propose a new single-blind study to test our hypothesis. Subacute stroke patients with upper extremity paresis are recruited, screened for contraindications, and randomly assigned to a group. Then, baseline motor function is assessed with the Wolf Motor Function Test, Fugel-Meyer Assessment, and Brunstrom Recovery Criteria. Our control group will receive mirror therapy alone, while the experimental group receives therapy with our proposed MEE device. Treatment is administered for 30 minutes 5 times a week for 3 months, which is the typical minimum duration of stroke-induced paresis recovery. Additionally, motor function is assessed as previously described throughout treatment. Finally, this data will be compared and analyzed to evaluate the therapeutic potential of our MEE device to reduce recovery time for subacute stroke-induced upper extremity paresis compared to mirror therapy alone.